So welcome everybody. Let me add my personal welcome to you. Thank you very much for taking the time out of your busy schedule to come visit us here in Waltham. This is our headquarters, one of our two headquarters. We're a dual headquartered company in Herzliya, Israel, and here in Waltham. We also have an R&D facility, which is just down the street in Needham, and then another one in San Jose, California, as well as the R&D over in Herzliya. So we're very glad to have you here. We do some of our solutions development, so you got a chance to tour the lab. And with us today, you're going to have Brian Carmody, our CTO, and Eric Kahlberg. Eric is the head of our business line head of our cloud business, and he's going to be talking to you as well. What we set up for you is I'm going to kick things off, and I want to talk to you a little bit about what's happened since we last met. There's quite a bit that's happened in the last couple of years. I find it really hard to believe that it's been 2.5 years, but it really has been. Brian is then going to talk to you in much deeper dive than I'm going to do for you on the foundational technologies that we bring to the table. And then Eric is going to talk to you about some of the challenges of storage and cloud today and how those challenges are being faced by INFINIDAT. And then Brian will come back in and he's going to take you on sort of a glimpse into where we're going a little bit beyond what we're talking to you about up front today. So hopefully that works for you. We think it's going to be really, really great. Of course, we're a little bit biased. You guys are the ultimate arbiters of that. So we didn't put any seatbelts on the chairs, but hopefully it's great. The one thing I will say is I'm really glad we added extra power to the table looking at these cords laying around the table. So again, I'm Doc DiRico, and I'm part of the Office of CTO. And one of the things I wanted to do is I wanted to start from a foundation. As hard as it is for me to want to admit, I've been in this business, I'm coming on 40 years now. Sadly, I look in the mirror every morning and it reminds me that I'm coming on 40 years now, but over 2 decades of that, 2.5 decades actually, has been spent specifically in the storage industry, over 2 decades at a company you're probably familiar with called EMC in a variety of different roles. And the reason I bring that up is because I remember when I started at EMC, databases, some of you probably will remember, you've got a similar complexion to mine called gray. You might remember databases back then had single-digit gigabyte type scale. As hard as that is to believe today, that was considered large in around 1994, right? Double digits was considered a very large database, double-digit gigabytes. But to a large extent, those were kind of empty. There were a lot of sparse tables in those databases. And at that time, I was part of a team that built the very first terabyte database. And why did we do that? Because EMC brought to market this crazy visualization of storage that was 3 floor tiles big, 17 square feet big, full of 9 gigabyte Winchester drives, and a little bit over a gigabyte of memory called the Symmetrics. And it was scoffed at. People in the industry looked at it and said, you guys are crazy. What the heck are you going to do with an entire terabyte? This is nuts. Right? Well, obviously we can laugh about that today. I'm pretty sure.
I laughed about it because of the IBM laptop at the top.
Fair enough. But I'm sure looking around the table, most of you have at least a terabyte right in front of you, don't you? Right? But at the time, it was this crazy radical idea. And in fact, we did build that first terabyte database. It took quite a while because the software architectures weren't designed for it, even though we were ready for it. We being EMC at the time, the software architectures weren't ready for it. The hardware wasn't necessarily really ready for it either. The servers and the networking didn't really exist yet. But we built it. And very quickly beyond that, we built 4 terabyte, and beyond that, we built an 11 terabyte, which I still laugh at, because for those of you who might remember it, it occupied an entire stage in an auditorium, and we actually had to crawl underneath it to shore up the stage. We were afraid the storage was going to fall through the stage. And then not that long after that, 30 terabytes, the industry really radically evolved. And it's important. It's important to tell part of the story, because when we think about the founding of INFINIDAT and why we are where we are today, we are all about going after that now petabyte scale. Back then, terabyte data centers, you could measure on one hand. You could count the number of people who had more than a terabyte deployed on one hand. Today, that's a joke. Drives are more than a terabyte, right? Today, the petabyte data center is at the cusp of growing into reality, and not just the petabyte data center, but the petabyte application. And INFINIDAT was founded on that fundamental principle. INFINIDAT was founded on the fundamental principle that we see not only the petabyte data set being a reality, but also that it needs a different storage paradigm. It needs one that can scale. It needs one that can be managed. It needs one that can be performant, and it needs one that can be cost effective. And this is what we were founded on, but we were also founded on the principle that not only could we make fundamental radical shifts in business, we could also make fundamental radical shifts in society. So where are we today? I'm sure you know the history of INFINIDAT and how we were founded. I'm not going to go through that. But when we last met, we had released a product at the very, very end of 2013. We were shipping product, and when we met, it was just after we had received some funding from TPG. TPG put an investment in the company, which allowed us to build this facility here. It allowed us to grow in EMEA. It allowed us to grow in APJ. It really set the wheels in motion for some rapid growth. And then only a couple of years later, we accepted some more money from Goldman Sachs. And Goldman Sachs gave us the money, the opportunity to accelerate some portfolio expansion that we had already been working on. And the portfolio expansion came from our own customers. The customers said, we love your stuff. We think that there's great opportunity to do more with it. And these are the types of business problems we'd like you to help solve. Now, if you look at these names, Goldman Sachs, TPG, these are not, rinky-dink VCs. These are not people who are just trying to do angel funding for a couple of startups. These are pretty significant names. These are people who are making significant investments. And in fact, it was Goldman Sachs who I believe was quoted in the press release that said, we believe that not only are they doing really innovative things with technology, but the profitable growth that they present is a great foundation for the future. And you can get the specific quote. It's on our website. This is really important because through this entire cycle, we've had 19 consecutive quarters of consecutive revenue growth. And not only revenue growth, but as you can probably guess, in 2015, and I know there are a few faces in the room who were there, so you can keep me honest on this, we said that we had deployed 250 petabytes of storage by the time we had that first meeting with you out on the West Coast. Anyone venture a guess at where we are today?
Gonna hit your first exabyte?
The first exabyte? How about 3.5? Okay, as of last quarter, Howard made a comment earlier, so I gotta love how he provokes the thought process. We're 2 days away from the end of the quarter, right? So this doesn't include this quarter's numbers, right? So as of last quarter, so in just barely 3 years, right? Just barely 2.5 years, we've grown 10x in deployed capacity. This is a real testament. We've broken records along this journey, and it's a real testament to not only the belief that we had in the growth of this industry, but in the way people are deploying new capacities to solve new business problems. It's really exciting to see some of the ways our customers use this technology. Whether it's cyber tech or cybersecurity or whether it's new paradigms for analytics. There's one company, a medical company, that's actually using our technology as the foundation to be able to get so granular in the images they can actually do a better job at detecting cancers than the human eye of a radiologist with years and years of education and experience. So this is really fundamentally cool stuff. Now, the product itself has evolved too. When we last met,
Thanks.
we hadn't yet delivered version 3. We had delivered 2 major instantiations of the product since it was first shipped. And through each instantiation, we made the product better. Right? I'm sure everybody's got one of these in their pocket somewhere or something close to it, right? This is an iPhone 10, little shout out to Apple. It's a great device. I've had it a few months, kind of like it, except that I have to put new software releases on it fairly regularly. And every time I put a software release on it, it gets slower. I haven't quite figured out why, but it gets slower. And by the time their next generation comes out, iPhone 11 or iPhone 2019 or whatever it's going to be, I'm sure I'm going to be compelled to buy another one because it's going to annoy me so much that I need to start over again. But yet, customers who started with INFINIBOX have seen their platforms get faster and faster and faster with each successive software release. And not only did we release new performance enhancements, we released new feature function. And in 2017,
So no planned obsolescence for you?
no planned obsolescence in the pipeline for this. And as we moved into 2017, with R4, we released even more functionality. We released synchronous replication. Back in 2015, we released native NAS. 2016, inline compression. In 2017, synchronous replication. QoS for our cloud service providers and some enterprises who are operating in multi-tenant type environments. And throughout each release, better and better performance. And the real secret sauce here, guys, is that we're not charging our customers extra for this. They get the benefits of the additional feature at no additional cost. They don't have to go buy a software license for a feature function that they should fundamentally have as part of their storage. And then, as we already said earlier, in the 2018, we released a new portfolio of products. We bumped up the size of the INFINIBOX by 2x at the same performance paradigm, right? It's the same performance profile. It's the same footprint, but we added 3 additional products as well: InfiniSync, InfiniGuard, and Nutrix Cloud. So that's where we are today. Now,
Doc?
Yes, sir.
What's TreeQ?
So TreeQ is, think about the open systems version of, or I shouldn't say open systems, it's the open source version of Qtree, right? It's for the NAS space. And we can talk about that a little bit more later if you want to get into detail on that. Okay. I wanted to, though, spend a couple of minutes on foundational technologies for you here. One of the key foundational technologies that we bring to the table is what we refer to as our neural cache. Okay? This is our machine learning data path with the algorithms that learn and adapt workloads as they come in and out. This is not, this is our secret sauce to the system. This is what takes these layers of memory media that have different profiles of how they perform and behave and makes them work in an integrated fashion as a true hierarchy. This is not stuff it somewhere and then in some post-process later move it around. This is real-time stuff, move things around. And Brian will take you through a little bit more detail how that works. We also have InfiniRAID and RAS. We got to have that because we deliver 7 nines of availability. We deliver 7 nines of availability using commodity hardware, which is also important. That's part of our cost-benefit profile. Right? We're delivering essentially a software product. It's a distributed RAID implementation that provides the reliability and resilience of the storage infrastructure, but at the same time, it also participates in how we leverage the INFINIBOX for performance. It's a massively parallel I/O operation that gives us great benefit. And then InfiniSnap. InfiniSnap may sound like a feature to you, but it's also an underpinning of how we move information around the system. InfiniSnap gives us zero performance impact because we're not literally creating copies anywhere. We're just leveraging the metadata associated with information, and there's almost no overhead to it other than the incremental data that you may write to a snapped copy. The timestamps versus locking mechanisms and copy mechanisms have great advantage not only in how we deploy InfiniBox, but also how we deploy other products, whether it's InfiniGuard or Nutrix Cloud.
Quick question on Neural
please.
Cache. What's the machine learning platform that you're using? Is it all custom developed?
This is all patented utilization, and Brian will take you into some of how we do this. Okay, we've taken some, they're not all necessarily new concepts, but how we deploy them are fundamentally new. Now, when we take these foundation technologies, they help us solve a problem that allow our customers and the businesses who use our products to essentially have it all. I'm sure you can realize, yes, you can have a system that's potentially more performant. It's hard to find one, but you can have a system that's more performant as long as you're willing to pay for it. You have to pay for performance. You can have a system that is performant, that scales, that's going to cost you even more. You can have a system that's more performant at a lower cost, but it's not going to be quite as reliable. Okay, there are a couple of three-digit names out there who are definitely in that reliability category. But to get performance capacity and reliability, availability, and serviceability at a reasonable cost point, something where you can demonstrate value and ROI to your business, that's where our sweet spot is. In addition to that, we've now expanded the portfolio, and it begins from the concept of our business continuity technologies. And it starts again with InfiniSnap, and I talked to you about InfiniSnap already. So I'm not going to talk to you about it again, except that it is the underpinning for our replication technologies. It's the same underpinning for our async replication as it is for our synchronous replication. An async replication gives you a zero performance impact replication for both SAN and NAS with a 4-second replication interval. The 4-second replication interval roughly equates to a 4-second RPO, depending upon the usual variables. Distance, the amount of write change, the bandwidth of the media, and things like that. Right? So add whatever overhead you want based on distance, and it will of course increase the RPO, but the interval is 4 seconds. It's the lowest in the industry. For sync replication, we also have native in the box 0 RPO synchronous replication that's also built off of InfiniSnap. It is a fundamentally different approach. We've essentially taken technology that was written in the early 1990s and redefined it. We've changed the status quo. We've redefined how the protocols work. We've made it a lot more effective, and we have a 400 microsecond latency as the baseline for the synchronous replication.
Using snapshot, redirect on write.
We're using our
provide synchronous replication.
It's not just a redirect on write. It's a metadata timestamp that gets added to define the redirection, and then of course the remote echo for the acknowledgement, the write acknowledgement.
And that's the maximum latency.
That's the baseline latency of the system.
So what's the maximum? So you're talking to a customer?
The maximum latency is, of course, the distance, but the distance is going to be better because we don't have quite the chattiness of the remote protocol. So the chattiness of the remote protocols, we're at least 35% better in the remote protocol. So where another technology, you might use, say, an extra millisecond per 100 miles or so, take essentially,
okay, Doc.
65%.
I'm confused.
Okay.
Because when you say synchronous to me, then that to me means data is safe in the second location before the application gets the acknowledgement.
Correct.
Writes to both simultaneously.
Well, he's they're talking about it's based on the snapshot mechanism, and there's 400 microseconds of latency.
Wow.
That's in the
And that
data. That's
doesn't sound
400
like it-
microseconds to package and ship the remote. And then you got to add the distance, and then the acknowledgement will come back.
but that 400 microseconds is in the data path.
That 400 for
Yeah,
sync is in the
that's-
data path. Yes.
That's right.
That's package and send time.
Correct.
Right.
So you're creating and building the metadata package that's logically a snapshot for every write transaction?
What's behind the curtain?
Yes.
Understand
Everybody else.
Okay.
where it's being thing.
That is,
That's different, but still
it's
synchronous. Okay.
quite a bit different, and it's quite a bit faster. I mean, if you look at it, it's significantly faster than anybody else's, baseline latency for synchronous replication.
Typically don't talk about baseline latency, what that really is. It's
Because
kinda unusual.
Because
right?
the distance is the variable, right?
Right,
And the,
right.
and the variables always
Right.
do matter when it comes down to it. In fact, in most cases, synchronous replication isn't very effective beyond a few hundred miles,
Yeah.
right?
Yeah.
Because
So,
the latency goes up, the performance of the application starts to tank.
Craters. So, I mean,
And what's the maximum distance?
There really isn't a maximum distance, although we tend to. I think we've only tested it out to something like 500 kilometers.
Because normally when I talk synchronous replication with customers as a partner, the distance depending upon the fiber networks and the service providers that you've partnered with, right?
Right.
The distance can vary versus the round trip time, right? Normally it's the round trip time, the RTT,
Correct.
in milliseconds. That's normally the threshold. There's a maximum threshold there for synchronous replication. So that's why I was asking that question.
Yeah, well, there's still this baseline latency that has to occur, right? And the baseline latency is usually, the write I/O plus some overhead of managing the dual write plus additional overhead for recovery. All right, so that's why we took that.
The question I have, Doc, is why package up a snapshot in order to replicate effectively a written block?
I think it really has to come back to understanding the basics of how we do snaps being a little bit different. And maybe Brian can answer that question.
Okay.
It seems to me it's just pushing that where the logical splitter function is down in the I/O path later.
It has more to do with how we manage the metadata hierarchy
Snap is a
associated with the
metadata
data.
scenario versus just taking some data and
Versus
slamming it
grabbing
across the line.
grabbing it high in the I/O stack
Yeah,
and
just
splitting
bring
it
it
there.
Right.
Yeah.
Splitting it at that.
Yeah, it's just they're letting
Yeah.
it come down further.
That's fair enough.
Yeah, and the distance question, it's kind of the maximum distance the vendor allows is always more than the maximum distance the customer's application can survive.
Exactly.
so-
And this is why you start to get
So you're fudging on that
multi-hop
because it's not
scenarios.
practical.
It's not practical, exactly. You get into multi-hop scenarios. You get into these, parallel, remote replications. Try to say that with my teeth in my mouth. Right, where you've got a close-by bunker site, and either that bunker site is replicating longer distance asynchronously, or you're doing a sync replication to the bunker and an asynchronous replication. So one of those paradigms is what comes into play, which actually starts to set me up for the next slide. When InfiniBox, when we did the portfolio announcement, one of the things that we added was we didn't revisit those feature functions except to point out that in InfiniBox we did announce a larger capacity system. So we essentially doubled the capacity of the system. Again, same performance profile, same footprint. And then we also introduced, this is where we started to get into, we introduced InfiniSync. Yes?
Presentation tip, never say double without two. How big is
Okay.
it now?
It's 2.
Well, no,
It's 8 point,
if you doubled it to 1 terabyte, I wouldn't be
8.6.
impressed.
8.6.
Okay.
2x. So I said 2. 2x. 8.6 petabytes in a footprint.
And we're still maintaining a cost per gig around $1. Is that?
The
that
cost
gotten
per
better?
you want to Sorry, Brian.
Oh, sorry, put you on the spot.
They put Brian on the spot. The question was the cost per gigabyte. Are we maintaining the cost per gigabyte? I think.
Yeah, so the awesome thing about InfiniBox is the larger the systems get, the cost per gigabyte drops precipitously. So for these large systems, at least I'll give you OpEx pricing. I mean, we are comfortably below a penny per gigabyte month for these.
Per gigabyte month.
Per gigabyte month.
Okay. I'll do some math.
So the next box here. So did I answer your 2 question, Howard?
Yep.
Yeah, okay. So the next product that we announced just a couple of months ago was INFINIDAT.
That's what I figured.
And it really solves that problem that Howard and Ray were talking about, right? It solves that problem of what if you need RPO 0, but you need a distance that just isn't practical for whatever reason. You're in the fault line, and your nearest reasonable location is arguably going to be, many hundreds to over 1,000 miles away. How do you solve that problem? So what we've done is we've packaged INFINISync, which allows you to replicate asynchronously over the thousands of miles, and then keep the deltas, the difference between the async replication and RPO of 0, in a black box. And this is a hardened black box that can survive just about anything you can foresee, man-made or natural disaster, fire, flood, impact, and it can sit in the same data center floor. And then it can operate independently of any outage, communication or power outage in the facility. And in the absolute worst case, if you lost cellular communication in the vicinity, in the absolute worst case, you can pick up the important components, the black box out of the hardened chassis, and physically relocate it and resynchronize using just a VM at the remote location. Now, it's not in that scenario RTO comes into play, but RPO is still maintained at 0. Another product that we introduced was INFINIGUARD. INFINIGUARD came from customer demand. Customers said, we love this technology. We're going to start, it's so cost effective, though, we can also use it for backup to disk. So they started using it not just for their primary workloads, but also for their backup to disk workloads. They said, boy, it would really be great if you could just integrate directly with the backup software and maybe provide inline data deduplication. So we did things a little bit differently using the same technologies, data deduplication technologies that you might expect that are pretty broadly used in the industry today. We've done some licensing there, and we put it in our own packaging. And by putting in our own packaging, we came up with a hardened, 2+1 data deduplication engine inline. But the benefit of providing it in conjunction with InfiniBox is not only are we achieving better backup times, but we pleasantly surprise the customers by giving them better than expected restore times.
So is InfiniGuard is an InfiniBox with deduplication?
It's InfiniBox with inline deduplication for backup. And it's obviously it's a different type of deduplication than you would use for primary storage. So that fundamentally is InfiniGuard, and that the video for that is available on our website if you want to drill into that deeper, or we can set up a follow-up with you to discuss that in greater depth. And then the last thing we introduced was Neutrix Cloud. We introduced a new paradigm for sovereign storage to enable multi-cloud workload paradigms, but also to enable competition between clouds. And I don't want to spend too much time on this because Eric's going to talk to you a lot more about that in a short while. So what I'd like to do, though, is I'd just like to leave you with this thought. One of the things that we do is not just solve the data center problem at petabyte scale. We solve the performance problem, we solve the reliability problem, we solve the manageability problem, we solve the cost problem. But at the end of the day, this isn't about us. It's about some really cool things that our customers are doing with our technology. It's really fundamentally about them. And you know what? It's been a lot of fun. It's been a great ride. We've done a lot in the last 2.5 years, and we certainly hope that you're with us for the rest of the ride.